The next section is 3.2, which is factoring trinomials. So a trinomial looks like this. This is the form it comes in. It'll have an x squared, then it will have some number, and for right now we'll call it b, and that number will have the variable x, and then at the end it will have what's called a constant, c. So the b, I don't know why I made that a capital C, the b is a coefficient, and then the c is a constant. There's also a coefficient 1 right here, but as we've talked about before, they don't really write that, so that you won't see it. This is a trinomial, and so an example of one with all the numbers in it would be something like this. X squared plus 5x plus 6. It should look familiar. When we multiplied binomials, when we FOILed, we ended up with a trinomial. So we are now learning how to go backwards. So let me explain that. Like a couple sections ago, you learned how to take x plus 2 times x plus 3 and simplify it. Get rid of the parentheses. And so just to bring back to that, and I told you that was one of the most important things in algebra. Going backwards is a big part of it. So when we went forwards, they called it FOIL in your book, and we kind of talked about that. You multiply the first term, so x times x is x squared. And then the outer terms, that's where the O from FOIL comes from. So x times 3 is 3x. And then the inner terms, so that's the I in FOIL, so 2 times x is 2. Oops, I forgot the x on the 3. Let me try that again. 3x plus 2x. And then the last terms, the L in the FOIL, and 2 times 3 is 6. And then we talked about how these two terms in the middle are like terms, so you can combine them to simplify it farther. So you get 5x plus 6. So this right here is the trinomial. And before, we were going from the binomials to the trinomials. Today you're going from the trinomials to the binomials. So your goal is to write these two binomials that come from a trinomial. So we're working backwards. So if we're working backwards, kind of look at the pattern backwards for a minute. It'll probably help you understand it a little bit easier. If you take a look at this, the 3 and the 2 add up to that middle number, that b. And then if you think about the 6 comes from 2 times 3. 2 times 3 makes 6. And then, so the middle term is taking the 2 and the 3 and adding it together, and the last term is multiplying them together. So with that in mind, let's do one of them. So if I have x squared plus 6x plus 8, and I want to find what that middle part is, I know the first term is going to be x squared, right? And let me erase that. Let me start at this a different way. I know that it's going to factor to two binomials, and I know that the only things that make x squared is x times x. So I know that for sure. It's these back numbers that become tricky. We just talked about what they added and what they multiplied to. So think about this. They're going to add to 6, and they're going to multiply to 8. There's a reason why I was trying to put the multiply first. So I have to find a pair of numbers that add to 6 and multiply to 8. It is easier, there's more things that add to 6 than there are that multiply to 8. So if you start with multiplication with the factors, it will help you. So the factors of 8 are 1 and 8. and they add to 9, so that doesn't work. The factors of 8 can be 2 and 4, and those add to 6. So bingo, we found the 2 pair that work. So that means that a 2 and a 4 go in here. It doesn't matter which order you put it in, because you're going to multiply the binomials anyway. Okay? And those were positive 2's and positive 4's. One thing I want you to remember, this class only factors trinomials with a 1 out in front, a leading coefficient of 1. But when you get to the next class, I don't know if it's E or F, that have factoring trinomials with a leading coefficient that's more than 1, the 8 is really coming from multiplying the outside numbers. 1 times 8 is 8. So when I drew that red line from the 8, that's only because the front of the trinomial is a 1. Just kind of keep that in mind if you're going to do the whole series of math, and when you get to that point, that teacher will go over that too. So if I think the answer is x plus 2 and x plus 4, I can always double check myself. Not that you're going to want to do this on every problem, but if you have a test and it only has a couple of problems and you have 50 minutes or whatever you have, and you have time to double check, then double check. So x times x, x squared. X times 4, 4x. 2 times x, 2x. 2 times 4, 8. So x squared plus 6x plus 8. We're back where we started. Okay? But the answer is this. We're looking for this form right now. We're not looking to simplify it, we're unsimplifying it. Alright, so let's try another one. And like I said, this is huge for algebra. If you're going on, this factoring is huge, and it seems like it takes a long time at first. Force yourself to do a bunch of them, and then once you get the hang of it, if I were you, I would force yourself to do 1 or 2 every night anyway. You can just make them up, because you can always check to see if you did it right. The faster you become at these, the more you do them, the faster you'll become. When you get into those upper level classes, there's a lot of factoring, and you're going to want to be really quick at it. I know at first that they're slow. So the next one is x squared plus 7x plus 12. I teach an algebra class and in the middle school, and we spend days on this until they get fast, and it pays off later when you get to quadratic equation. So you're looking for something that multiplies to 12. So it multiplies to 12 and it adds to 7x. Kind of making a mess of this. You're always looking for something that multiplies to the combination of the outers and adds to the inner. So things that make 12, 1 and 12, that's not going to do it. 6 and 2, that's not going to do it. 3 and 4. The reason I'm saying that's not going to do it is because in my head I'm adding these. 12 and 1 makes 13, 6 and 2 makes 8, and then 3 and 4, that makes 7. So 3 and 4 are the magic numbers. So then you just go x plus 3, x plus 4. Done. You try this one. Maybe pause it and see if you can do it. Whoops. It would be nice if I gave you the right numbers. It would be bad if they didn't work and you couldn't do it. Although we do some of those later. Okay, so pause it and try and do that one. So if you've already done it now, it's multiplying to the outside. So 1 times 30 is 30. So it's going to multiply to 30. And it's going to add to the inside. So it's going to add to 13. So 30 and 1. And any time when you can't find it, I always get students who do not want to sit there and write a bunch of stuff. If you are stuck and you're like, there's nothing that multiplies to those, start writing it down. Let's see, it ends in a 0, so 5 goes into it. So 6 and 5 ends in a 0, so 10 goes into it. Whoops. As I said, 10 goes into it. Having a hard time here. 10 times 3, and bingo, that's it. It makes 13. So x plus 10, x plus 3. Now again, you could say it this way, x plus 3, x plus 10. That's that commutative property. It doesn't matter which way I do it. I'm going to multiply them all in the end anyway. Okay, and you could double check by foiling them. Moving on. How about this one? X squared plus 9x plus 20. And really, just force yourself to do a bunch of them. You know, if you don't want to make them up, because I guess making them up might not be a great idea, just because what if you come up with ones that are prime? But, you know, in the back of the book, there's a bunch more, ones that I don't assign. Or get on the internet and just say, you know, factoring trinomial practice. There's a website called AAAmath.com, and a lot of times I'll get my middle school students to get on here, but the content goes all the way up into college, and you just tell it what you want to practice, and it'll tell you right away if you're getting them right or wrong, so you don't have to wait till the end. It's not like a big worksheet. You can just type in what topic you want, and it will do it for you. So that's a really good website to practice. So back to this problem. So it's multiplying to 20, and it's adding to 9. So 1 and 20. 20 ends in a 0, and it's an even number, so 2 and 10. 2 always goes into numbers that end in even numbers. When it ends in a 0, 10 goes into it, and so does 5. So 5 and 4 and 10 and 2, and bingo, I can stop right there. 5 plus 4 is 9. So x plus 5, x plus 4. Now again, there's a way of doing these that's a regrouping way, but when the coefficient is 1, it's faster just to do it this way. When you get into that other class, they'll show you how to deal with that coefficient that isn't 1, and then you will use your regrouping skills. Hopefully they teach it that way. What if these aren't positives? Let's talk about what happens then. So let me give you a problem here. So x squared minus 7x plus 10. Remember a while back at the beginning of the videos, I don't know if you watched them at the beginning, but I talked about bubbling terms. This 7x goes with that minus, and this plus goes with that 10. And so keep that in mind. So if we're going to find factors, and we want to look for something that multiplies to positive 10, but it adds to negative 7. And so that's important. So if it adds to negative, but it's two numbers that multiply, think about what those numbers have to be. Are both of them negative? Is one of them negative? Or are they both positive? If you have two positive numbers and you multiply them, you're going to get a positive answer. If you have one positive number and one negative number, let's do this. Positive 10, negative 10, and positive 1. Then you're going to get something that might add to a negative. Okay, so this adds to positive 9, but this one adds to negative 9. So because they multiply to a positive and add to a negative, we know that one of them's positive and one of them's negative. Okay, so that didn't work. So 5 and 2, whoops. So negative 5 and positive 2, or positive 5 and negative 2. So let's look at that. So negative 5 plus 2 is negative 3. And I just screwed this whole video up. Dang it. So let's look at trinomials with negative signs in them. So if I have this trinomial, I know that this negative goes with this 7x. If you think about, if you watched my videos way back at the beginning, we talked about circling or bubbling terms. I know that the negative goes with the 7x and the positive sign goes with the 10. So just keep that in mind as we go through this. So we're looking for something that multiplies to 10, but it adds to -7. I should just put add. So if something's going to multiply to a positive and add to a negative, that means that both of them must be negative, because a negative times a negative makes a positive. So that means both of these numbers that multiply to 10 have to be both negatives. So -10 and -1, that makes, if I add those together, that makes -11. -5 and -2, if I add those together, it makes -7. So that's the case. If you're not really good at adding negatives, especially if one's positive, one's negative, make sure you're using your calculator to double check yourself. Okay, so I know that the two numbers that work, our magic numbers, are -5 and -2. So I can just put them right in. X minus 5, X minus 2. Now it does get tricky with the positives and negatives, so you want to make sure that maybe in your head you FOIL it back. The more you force yourself to FOIL back in your head, the faster you'll get at foiling. And that is so important if you're going on in math. So that makes x squared -2x, -5x, which both add up to the -7. And then I multiply these two, I get a positive 10. So let's try another one here. X squared minus 8x plus 15. Maybe you want to pause it and figure it out for yourself. It multiplies to 15 and it adds to -8. So that means that both of the numbers must be negative. So that means that I'm going to have x minus and x minus. Like I said before, I'm the worst person at details, and so sometimes I will force myself to put those signs there first and then play with the numbers. So I've got -15 and -1. That adds to -16. I have -3 and -5. Those add to -8, so bingo. So it must be -3 and -5. Here's another one. So it multiplies to +18, but adds to -9. So again, that means they're both negative. So y minus and y minus. -18 and -1. That makes -19. The reason why I always start out there is people forget that one, and then when it does become that number, like if it was -19, we were looking for the middle, I find that people go, oh, I didn't even think about that because it's so simple. -9 and -2, those add up to -11, so that didn't work. 18 is an even number, so we tried 2. Let's see, 6 and 3. -6, -3, and bingo, there we go. So -6 and -3. What if both of these are negative? So let's try to do one like that. So there's 3 types. There's ones when everything is positive, there's ones when the middle term is negative, and there's ones where the last term is negative. Also, if you ever run into any problems that aren't written in this order, like let's say that the problem ended up being like this. Say this is the problem that they give you. Rewrite it to be in what they call descending order. So the highest degree first, so the x squared first, then the x, then the constant, the thing without the x. Okay, it's really hard to factor when they're in this form. So we're looking for something that multiplies to -4, but it adds to -3. If it multiplies to a negative, then it's got, one of them has to be positive and one of them has to be negative. That's the only way, whoops, I don't know what I was doing there. That's the only way you get a negative. Okay, and then if it adds to a negative, I don't know how comfortable you feel with adding positives and negatives, but if you remember way back, like in middle school, if it adds to a negative, that means that the bigger number is 3 bigger. So the difference between the numbers is 3, and the larger, not the larger number, but the larger absolute value of the number. So let me explain. So like if you have -1 and 4, those two add to a +3. But if you have +1 and -4, those two add to a -3. So my little trick with these is that if I know that one's positive and one's negative, I look here and I say, what two numbers are 3 apart? Well, 4 and 1 are 3 apart. And so I know that it's 4 and 1, and I know the negative goes on the 4 because there's going to be negatives left over. So x minus 4 and x minus 3. Whoops, one of them's, what am I doing? Wow, issues today. +1. X minus 4 and x plus 1. So let's double check since I keep having issues today. X squared plus 1x minus 4x minus 4. So x squared minus 3x if I put these two together. Minus 4. Phew. So this is your answer. Whoops. This is your answer. So why don't you try this one? X squared plus 7x minus 8. So I'm looking for something that multiplies to -8, but it adds to 7. So I know one of them is negative and one of them is positive. So things that multiply to 8 are 8 and 1. If I put the negative on the 1, then that's going to make 7. Sometimes you get there on the first try. So 1 and 8. Here's another one. T squared minus 2t minus 24. So I know that it has to multiply to -2 and add to -24. So I'm looking for a number. Whoops, did I write that down wrong? Yes, I did. Maybe I shouldn't be teaching today. Multiplies to -24 and adds to -2. Okay, and so I know I'm looking for two numbers that are 2 apart. So something times something that makes 24, but they're 2 apart. So I know it's not going to be 24 and 1. So, I can say 2 and 12, and that's too far apart. I know one of them's got to be negative, so that's not going to work. So how about 6 and 4 are closer together, and they're 2 apart. So 6 and 4. I know it's got to add to a -2, so I'm going to put that negative on the 6. Because -6 plus 4 is 2. So I found those. T minus 6 and t plus 4. Okay. One more type of problems. Not all problems are going to be able to factor. And that's why I said, oh, maybe you don't want to make these up on your own, because you might end up making a lot of them that are prime on accident. Okay, so if I look at this problem, something that multiplies to 12 and adds to 9. So 1 and 12, that doesn't add to 9. 6 and 2, that doesn't add to 9, that adds to 8. So those two don't work. 3 and 4, those add to 7, so that doesn't work. And then I've exhausted the factors of 12. There's nothing else that makes 12. So then I know that this is prime. And so that's the way it is. I leave it that way. This does not break down to clean factors. Like the number 12. It can break down to, 3 times 4, right? But the number 11, the only thing that makes 11 is 1 times 11. So the only thing that makes x squared plus 9x plus 12 is x squared plus 9x plus 12 times 1. So we call that prime and we just leave it. There's a table on page 810. It's orange. Woo, not that big. This is really bad. And I have to make the next video today because I'm behind, so I feel sorry for some of you. I'll try to do better. Orange. It's an orange table. It kind of summarizes everything. And so it summarizes what do you do when the middle term has a minus in it? What do you do when the last term and the middle number have minuses in them or have negatives there? So you might want to take a look at that. Don't depend on it. Don't keep looking, don't use it on all of your homework, or at least don't use it on the skills checks, because you've got to start making sense of it for yourself. But it does kind of summarize it. Maybe that will solidify it in your mind. One other thing, actually there's two other things on this section. Remember last section where we talked about finding a GCF, always looking for a GCF. Always look for a GCF first. And I kept saying that's, it seems like that's a struggle. And every time I teach a class, like an actual class, I'll say, what do you look for first? And I'll do that for like 4 days until they're going GCF, GCF, GCF. This is one of those things too, that you want to look for a GCF first. If you don't, factoring becomes really hard. The numbers get really big. And so you want to look for that GCF and pull it out first. It'll make life so much easier. Okay, so if I look at my whole numbers, what's common between 7, 35, and 42? Well, 7's common between them, so I can pull a 7 out, and I get x squared plus 5x plus 6. Okay, so once you pull that out, then again, leave that down there so you don't forget it. But now factor this part. So you're looking for something that multiplies to 6 and adds to 5. So 2 and 3 are those numbers. So then you can go x plus 2, x plus 3. And again, once you do a bunch of these, it's like you find out they're using the same small numbers all the time. Most of the numbers are, less than 10, and so you get the hang of those patterns. So this is your final answer. So even though I didn't show you at the beginning, they showed at the end, because they want to start you out with simple ones, always, always, always look for the GCF first. Okay, so here's one more example on that. So 2x to the 4th minus 4x cubed minus 6x squared. So on the last one, I just looked at the whole numbers because I should have pointed out that not all of them had an x, so I didn't have to look at that. On this one, they all have a 2 in them, but they also all have an x squared in common. So it's that GCF. So if I factor that out, and remember, factoring it out is like last section, where remember you're mentally dividing it by 2x squared, dividing each of these by 2x squared. And it's okay if you write it down like that. So if I divide that first one by 2x squared, I get x squared. If I divide the middle term by 2x squared, I get 2x. And the last term, I get 3. At that point, I can now factor this. So it's got to multiply to negative 3, and it's got to add to negative 2. Notice that these are negatives. So if it's going to multiply to a negative, I know that one of them is negative and one of them's positive. And they're 1 apart. So what makes 3? The only thing that makes 3 is 3 times 1. Okay. Oops, add to 2. Ooh, almost screwed up there. I was like, wait a minute, those don't add to 1. So if it's going to add to a negative 2, that means the negative's got to be on the 3. So then I can go x minus 3, x plus 1. And I bring the 2x squared down. So there's my final answer. Where this is useful is a lot of times you are talking about areas, especially in algebra and in geometry. And so the last problem in your textbook, when it shows application, it talks about a rectangle, and it talks about that rectangle having an area that's written in a binomial, x squared plus 6x plus 5. Okay, so if you know that area is length times width. So if you can find out what times what makes that x squared plus 6x plus 5, then you'll know the dimensions of it. So it's got to multiply to 5 and add to 6. That's 5 and 1. So x plus 5, x plus 1. So that means that one of the dimensions is x plus 5. The other dimension is x plus 1. Okay. These trinomials that we're showing you, there's a lot of application in real life, and we'll talk about it as we go. These they get you ready for the quadratic equation and quadratics and parabolas. And parabolas, we use those in real application, like anything that, like a baseball that is thrown up in a curve, or a coin that's flipped, or a fountain where water is shooting out. Anything that comes up and comes down. And so we'll learn a little bit of that application in the next section.